For the majority of Calculus 1, we have been doing the process differentiation. So we've been finding the derivative. And now we're going to do something quite interesting. We're going to find the antiderivative and do a process called integration. So let's first introduce the antiderivative definition. So a function, capital F, is an antiderivative of a function if when you take the derivative of the capital F, it gives you back F. So for example, x to the fourth is the antiderivative of 4x cubed. You can check that because if you take the derivative of x to the fourth, you get back 4x cubed. So what's happening here is that when you go from x to the fourth to 4x cubed, you're finding the derivative. But when you go from 4x cubed to x to the fourth, you're finding the antiderivative. So you're going backwards. What's really nice for us is you're actually going to be able to check these answers. So when you're finding the antiderivative, you're going to be able to check if it's correct by doing it the other way and seeing if you get back the derivative. So let's do a few problems to kind of solidify that. It's asking us if 2x plus 5 times x minus 6 is an antiderivative of 2x plus 3. So if it's true, we should be able to take the derivative of f, the capital F, and get back 2x plus 3. So let's take the derivative of capital F. Now we could use the product rule, but I prefer to FOIL out and then find the derivative. So that's going to give us 2x squared plus 5x minus 12x minus 30, which will give us 2x squared minus 7x minus 30. And then I can easily take the derivative with the power rule, 4x minus 7. But 4x minus 7 is not 2x plus 3, so the answer is no. This is not an antiderivative of 2x plus 3. Okay, let's do another type of problem. It gives us three functions, 8x to the fifth plus 10, 8x to the fifth minus 7, and 8x to the fifth minus 3. It wants us to differentiate all three of them. So I'm going to have f prime of x is equal to, by the power rule, 40x to the fourth, and then the derivative of 10 is 0. G prime of x is equal to 40x to the fourth, and then the derivative of 7 is 0. And h prime of x is going to equal to 40x to the fourth plus 0. So what's important to note here is that f, g, and h are all different functions, but they all have the same derivative. And what's different about these three functions is the constant at the end. Because no matter what, a constant, the derivative of a constant is always 0. So 8x to the fifth plus 10, 8x to the fifth minus 7, and 8x to the fifth minus 3 are all the antiderivative of 40x to the fourth. So what we call this is we actually call this the family of antiderivatives. And I'm going to show you the notation for that with number 3. So when they're asking you to find all antiderivatives, what they're trying to tell you is think about the constant. So we want to find all the antiderivatives of x to the fourth. Now there's a little note, a little help for us, which tells us that x to the fifth divided by 5, the derivative of that is x to the fourth. So remember, what that means is that if you go in this direction, this is the antiderivative. So the antiderivative, which I'm going to label as the capital F of x, is going to be x to the fifth over 5, but you have to do plus a constant c. And what c represent here is any real number. Now, you can use any letter to represent the constant, but normally you use c, capital C for constant. Another common one is the letter k. All right, but again, it's just to represent as a real number. How do you do that? We can check, because when we take the derivative of f of x, we get 5x to the fourth over 5 plus 0, and this is x to the fourth. So it works. This is the antiderivative of x to the fourth. So what you want to be careful of here now, and we're going to do another example of this, is that when you're finding the family of antiderivatives, you're going to add plus c. Because there are many functions that have the same derivative based on the constant at the end. The last thing we're going to see in this video is we're going to introduce a notation of how do we know that we want to find the antiderivative. So we use a symbol, a notation called an integral. So let's look at it together. So to represent the family of all antiderivatives, so now you know that it's the family because it's the plus c at the end, we use a notation called an indefinite integral. And the really important part here is the word integral. I will explain indefinite why. So we have the integral symbol. So this is the little big S. I mean, it's not an S, but just to kind of help, the little S symbol is called the integral sign. So the integral of f of x dx is equal to the antiderivative plus c. So it's equal to the, so when you have the integral symbol, you know that you're going to want to go backwards. So again, to go from this direction to the left to right is finding the antiderivative. Right to left is the derivative. Now, I want to make a really important point here. The important part, and I'll do this a lot in the videos with integration to kind of remind you, is that the integral symbol and the dx are married. So I'm going to highlight that. This symbol and this symbol are married together. They have to go, they're always together. So if one is there, the other has to be there. If the other one is not there, the other one is not there. One cannot exist without the other. So I'm going to show you 3 different examples here of how the integral symbol works. So in number 3, we found out that the antiderivative of x to the 4th was x to the 5th over 5 plus c. So if we look at our integration symbol, if we want to find the antiderivative, the integral symbol tells us that. So we work backwards, which we'll learn how to do that in the next video. And the antiderivative is x to the 5th over 5 plus c. So it has to have the plus c. We can check. We already did this above, but I'm going to do it one more time by taking the derivative of this. And the derivative of x to the 5th over 5 is x to the 4th plus 0. So this is x to the 4th. Check. Now the next one, the integral of 40t to the 4th dt is equal to 8t to the 5th plus c. We can check. 8t to the 5th plus c, the derivative of that is equal to 40t to the 4th plus 0, which is 40t to the 4th. Check. And the last one, the integral of 4y cubed dy is equal to y to the 4th plus c. So again, we can check. Y to the 4th plus c, the derivative is 4y cubed plus 0, which is 4y cubed. Check. So the integral symbol tells you you're going to find the antiderivative. Like I said, I'm going to show you those techniques in the next video. But the last thing I want you to notice about these integral symbol is look at the dx. So in the first one, the variable you're working with is x, so it's a dx. In the second one, the variable you're working with is a t, so it's dt. And in the third one, the variable you're working with is y, so it's dy. dx represents the dx, dt, dy represents that the anti-differentiation is being taken with respect to that variable. So pay attention to what variable you're working with.